Hey Algebra 2 students, it's Miss Goldenberg. I've learned how to do a little bit more with the tech side, so I can now have a little video here temporarily and say hi to you guys. We are officially starting our last unit, and this unit is going to be a little bit cut short given the timing of everything. So we're going to try and hit like the big ideas in this unit, and you will see a little bit more of this next year. This unit is all about counting, and we will use the counting to help us do probability as well. I didn't find a great math meme, so I just put this like corny picture of counting that kind of looks preschool-esque. And I'm hoping that you guys find it straightforward and easy, and it kind of brings back the happy days of math in elementary school and whatnot. So I'm going to pause the video so I can turn off my camera. That way when I make my computer turn into a tablet, you guys don't just have my hair all up on the camera the entire time. Okay, so the first thing we're going to do is we're going to look at some examples of counting. And we're specifically going to look at a menu, because the menu is a really good common example of a big counting idea that we're going to focus on. So Chili's is doing a promotional meal option with 2 choices of appetizer. You can either get a salad or chips and salsa, as well as 7 different entrees ranging from burgers to fajitas to ribs. And you only get 1 choice of dessert. I know, my favorite part too. It's kind of annoying that they only give you 1 choice. However, I am a big fan of their molten cake. I used to love getting it as a kid for my birthday. This fun fact, Chili's was always the place I would pick when I got to pick my special birthday dinner as a kid. And so we're going to figure out how many different meals you could possibly get out of these choices. And we're going to do something called a tree diagram. So tree diagrams start with your first choice. You can either have the salad or the chips, right? Now, if you have the salad, you then have 7 different choices for your entrees. So 1, 2, 3, 4, 5, 6, 7. And I'm not going to label them because that would be kind of annoying. And then chips, 1, 2, 3, 4, 5, 6, 7. You get the idea. And then what's kind of interesting about this one is you only have 1 choice for dessert. Now, if I had 2, I could do like, both of the choices. So dessert's going to be like the one choice. You really don't even have to do the dessert because there's only 1 option. So the question is, how many choices do I have? Right? Each of these branches, there are 7 of them, and there are 2 different sides. So I've got 14 options. Now, some of you guys might be seeing the faster way to get the 14 using our background, right? Seeing the 2, the 7, and the 1, right? We had the 2 here, the 7 this way, and the 1 option going along our third decision. And the shortcut is that you could do 2 times 7 times 1 and get 14. Now, I only wrote the 1 there just to keep that with the same structure. You don't really need to write the 1, but if you had a bigger number like 2, you would have a different answer, of course. So that kind of brings us to a big idea that you guys are going to either write in your notebooks, or you might have tried to print this. If you printed it, there's kind of just like a lot of type and a lot of big pictures, so it might not be the best one to print. It might be easier to just write it in your notebook. This is what's called the fundamental principle of counting. And it's the idea that if you have multiple choices that you are making, and you want to know how many options you have for the outcome based on those choices, you take number of choices, or I guess not choices, I would maybe say number of options, maybe, for choice number 1, right? And this might be number options choice 2, right? So what we did was we did like number of options for appetizer times number of options for entree, and so on and so forth. If you want to read this part, it's saying the same thing just in more mathematical terms. So it's saying that when you have a combined action or event in which the first action has a bunch of different ways that you can perform it, and the second action has a bunch of different ways that you can perform it, and so on. If you want to know the overall possible ways that things can happen, you just multiply them together. And that's just kind of a textbook definition. You don't have to write that down. You could kind of paraphrase it if you want and say, you know, if you have choices N, M, L, M, N, O, P, yeah, I'll do O, P, dot, 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 dot. And you have a bunch of different outcomes for each of them. Let's say there are N ways that the first thing can happen, M ways, right? O, P, dot, dot, dot. You could write it in something like that if you wanted. Yep, the top one's just more of a textbook way. So let's look at this. This one is a very typical problem. A lot of these kind of counting problems, you'll see license plates. You'll also see passwords. And you guys will see that in your homework on fundamental counting principle. You guys will do the homework tomorrow rather than today. Today, this is your only task. And in the homework, you'll have some problems where you look at license plates and passwords and think about how many possible outcomes there are, how many possible different passwords someone could have. So we're told that in DC, you have 2 letters. So I'm going to do letters in purple, followed by 4 digits. 2, 3, 4. I'm going to do those in pink. And the first digit cannot be a 0, but digits can be repeated. And when they say digit, they mean digits 0 through 9, right? 0, 1, 2, 3, and so on. That actually means that there are 10 possible numbers, right? Because you are doing 1 through 9, which is 9 numbers, as well as 0, which is the 10th number. And so let's see. If I'm looking specifically at my letters, I'm assuming that letters can be repeated because they didn't tell me. There are 26 letters, right? So options for letter number 1. And I'm assuming I can repeat. I'm just going to assume can repeat letters because they didn't say anything about that. And this is options for letter 2. Right? I'm going to multiply them. Just like before, I'm doing each decision, however many ways I can do it, times the next one. You can kind of envision like a tree diagram would have 26 branches for the first row, and then each of those would have 26 more, so it gets kind of cumbersome, so we don't really want to draw this one out. And then for the numbers, for our digits, it says the first digit cannot be a 0. So how many numbers do we have that are not 0? We have 9, 1 through 9. So you could make a little note here maybe. So numbers other than 0, right? And then it says after that, you are allowed to repeat digits. So it doesn't really matter what that digit is. Each of these can be any of the digits. So there's 10 options, 10 options, and 10 options. And then in order to calculate this, it looks like I have 26 squared times 9 times 10 cubed. That's just exponential shorthand. It'll help you guys do it in your calculator a little bit more easily. That way you don't have to write it all out. Okay, so I just calculated that on my calculator off screen, and that is how many possible license plates you have. In this unit, I think it's really, really important to make sure that you write this or this out before you do your answer. A lot of my students oftentimes just write the answer, and I think that it's actually more important to see the step before because that shows your thinking for how you arrive at that answer. Okay? This is for all my sports fans out there. I know you're probably unhappy with where we are in sports right now. So I think it was a little bit closer to March Madness maybe when we were doing it last year, or maybe, you know, we just thought we'd loop it back to something somewhat recent. So how many different possible ways could you fill an NCAA tournament bracket? And those who are better at sports than I am and know what's going on have informed me that there are 64 teams that participate in March Madness. And so let's just think about, like, as you were to start filling in your bracket, I think this picture is a little cut off, but you could imagine that, like, if this is my first grouping, like I'm, you know, putting 2 teams against each other. I have 64 options for the first team I choose, and then they're out of the running, right? So then I have 63 for my next one, For this pair, I have 62 options, then 61, and so on. So you can kind of see that it's going to be like 64 times 63, times 62, and so on, and that's going to fill all the way down until we get times 3, times 2, times 1, right? Until we arrive at that there's only one team left for the last slot. And then in addition to that, now if you think about that, like how many different options there are, 64 times 63 times 62 times times 3 times 2 times 1. That's a huge number. And that's only taking into account your first decision, right? It's not taking into account that for each of these, you're going to have 2 options for who wins, right? 2 options for who wins. And then as you continue, you're going to keep having 2 options for who wins. So it's going to also be times 2, times 2, times 2, right? There's going to be a lot of multiplying by 2. Just to think about how many options there are for your first bracket filling, I want to do 64 times 63 times 62 and so on. And there's actually a faster way to do that with our calculator. Okay, so with our graphing calculator, if I want to do 64 times 63 all the way to 1, there's a cool shortcut. If I do 63 and then do math, I'm going to arrow over to what's called probability. I'm going to scroll down to this exclamation point here, the 4th option. Press enter, and press enter one more time. That is representing doing 63 times 62 and so on. And it's called, I'll write it out here, 64, it's called 64 factorial. We call that factorial. And a factorial just represents taking the number and multiplying it continuously by the number one smaller than that, one smaller than that, until you get to 1. The mathematical way to write it out would be like n factorial equals n times n minus 1, right, times n minus 2, whatever is 1 smaller, 2 smaller, times dot, 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 times 3 times 2 times 1, if you will. And so that's just a faster way to type it out. If you look at that, that's 1.98. I'm just going to write it. I'm going to kind of ignore the rest of that. 1.98 times 10 to the 87th power. What that means is I would be taking this decimal point, and granted there were more numbers past 8, and I'm going to be moving it over to the right 87 decimal places. So you can imagine that Warren Buffett, who is offering $1 billion for a perfect bracket, should not be very nervous. It's near impossible to do that. Remember also, we only did choice 1. There are many more choices, like as you continue on in those brackets. Okay, some other examples of counting different possibilities. A lot of textbook problems also look at making up words. So if I have the letters A, B, C, D, and E, and I want to know how many 5-letter words, let's just, assume that a word is 1, 2, 3, 4, 5 letters in a row. So like A, B, C, D, E could be a quote-unquote word. So basically just how many different arrangements can I make if I use those letters, and I only use each letter once. So this is, if you think about it, choices for letter 1, right, for letter 2, and so on. So you're going to start with 5 options, but because you can only use each one, they're going to go down by 1 every single time until when you get to the last one, there's only 1 option left. This is really similar. We can also do this as 5 factorial, right? So if I want to do, I'm going to do second entry. That's going to pull the last thing I typed in. I'm going to delete and do 5. And 5 factorial is 120. And if you want to recall the calculator command to get there, we're going to do math, arrow over to probability, and factorial is your 4th option. So there's 120 different words that we could make. A lot of word problems rely on can you repeat letters or not. That's sometimes how we make them trickier or easier. Okay, I want you guys to try this one on your own for practice. Try number 4 and number 5. Okay, here's your answer for number 4. You should have gotten 50, 40. Number 5 should be 100 factorial. Calculator says it's too hard to handle though. If you want an extension from number 4, try number 4B. I'm going to pause it and work it out. Okay, 4B, my extension is a little bit different. If you only have one option for which book can be first, it ends up being only 720 ways. Okay, so that's it for our lesson on fundamental principle of counting and factorials.